In this video, I'll be doing an example of differentiating through the quotient rule. And here I have y is equal to x plus 1 divided by square root of 1 minus 4x. We know that we apply the quotient rule when we have two functions that are getting divided by each other. And then the derivative looks like this. And if we name the functions of f and g as just u and v, then the derivative would look like this. So now to differentiate this by using the quotient rule, my first step would be to identify the functions in the numerator and in the denominator. This is my function in the numerator. I am going to name this as u, and this is my function in the denominator. I am going to name this as v. Now I am going to differentiate both of these functions u and v. U is x plus 1, and when I differentiate this with respect to x, I'll get du upon dx, which we also call as u dash. The derivative of x plus 1 is just 1. Now I'll differentiate v. V is square root of 1 minus 4x. Square root we can also write as whole power 1 upon 2. So v is 1 minus 4x whole power 1 upon 2. Now to differentiate this, I'll need to apply the chain rule here. And in the chain rule, the power comes down first. So dv upon dx, which we also call as v dash, is going to be equal to 1 upon 2 times the inside function we write as it is, so 1 minus 4x, and the power gets reduced by 1, and 1 upon 2 minus 1 is minus 1 upon 2, and times the derivative of the inside function. The inside function is 1 minus 4x, so its derivative is going to be minus 4. Now minus 4 divided by 2 is minus 2, and this power is negative. To convert this power into positive, I'll shift this term to the denominator. So v dash would become minus 2 divided by 1 minus 4x whole power positive 1 upon 2. Now after finding v dash and u dash, I can go on to use the formula of the quotient rule, which is dy upon dx is equal to first v times u prime minus u v prime divided by v squared. V is 1 minus 4x whole power 1 upon 2. Then u prime is just 1, then minus u, which is x plus 1, and then times v prime minus 2 divided by 1 minus 4x whole power 1 upon 2. And this all is divided by v squared. V is this, so 1 minus 4x whole power 1 upon 2 whole squared. This is dy upon dx. This square, if I remove the bracket, would go inside and get multiplied by 1 upon 2. 1 upon 2 times 2 is just 1, so this becomes 1 minus 4x whole power of 1. And if I simplify the numerator by multiplying x plus 1 by minus 2, I would get dy upon dx is equal to 1 minus 4x whole power 1 upon 2, and then minus x plus 1 times minus 2 is going to be positive 2 times x plus 1 divided by 1 minus 4x whole power 1 upon 2, and then divided by 1 minus 4x whole power of 1. So this is dy upon dx. This is the derivative of this function. I could either leave my answer like this, or I could simplify it further. To simplify it further, I am going to write the numerator separately. I am going to simplify the numerator first and then put back in this fraction. The numerator is 1 minus 4x whole power 1 upon 2, then plus 2 times x plus 1 divided by 1 minus 4x whole power 1 upon 2. Now in order to add these two fractions, their denominator must be the same. So I'm going to multiply this 1 minus 4x whole power 1 upon 2 by this denominator. And so it would become 1 minus 4x whole power 1 upon 2 times 1 minus 4x whole power 1 upon 2 divided by 1 minus 4x whole power 1 upon 2, and then plus 2 times x plus 1 divided by 1 minus 4x whole power 1 upon 2. Now after the denominator is the same, I can add these two, and so it would become the denominator here 1 minus 4x whole power 1 upon 2. Now these two terms have the same base. When they get multiplied, their powers are going to get added. 1 upon 2 plus 1 upon 2 is just 1. So this is going to be 1 minus 4x whole power of 1 and then plus 2 times x plus 1. Now I'm going to multiply 2 by x plus 1 and I'll get 1 minus 4x plus 2x plus 1 and then divided by 1 minus 4x whole power 1 upon 2. Minus 4x plus 2x is negative 2x and 1 plus 1 is 2. So this becomes 2 minus 2x divided by 1 minus 4x whole power 1 upon 2. This is the simplification of the numerator. This was the numerator which we simplified into this form. Now I'm going to put back this numerator in this dy upon dx and I'll get dy upon dx is equal to 2 minus 2x divided by 1 minus 4x whole power 1 upon 2 divided by 1 minus 4x. This here is my numerator and this is my denominator. For fractions, we write numerator divided by denominator. So I can write this dy upon dx as the numerator, which is this, then divided by the denominator, which is this, 1 minus 4x. You might have learned from basic algebra that if we convert the division sign into a multiplication sign, then this term towards the right hand side of the sign gets reciprocaled. So if I convert this into a multiplication sign, then it would be 1 divided by 1 minus 4x. So dy upon dx is going to be equal to 2 minus 2x divided by 1 minus 4x whole power 1 upon 2 multiplied by 1 divided by 1 minus 4x. Now when two fractions get multiplied, the numerator gets multiplied by the numerator and the denominator by the denominator. These two terms have the same base, so the powers are going to get added. This 1 minus 4x has the power of 1 upon 2 and this 1 minus 4x has the power of 1. So this is going to become dy upon dx is equal to 2 minus 2x divided by 1 minus 4x and 1 upon 2 plus 1 is 3 upon 2. So this is 1 minus 4x whole power 3 upon 2. This is my answer. This is the derivative of this function.